So today we're going to cover Chapter 7, Section 3. Today we're going to prove that a quadrilateral is a parallelogram. What we're going to see today is all of the theorems that we learned in Section 2, we're now going to see converses for those theorems. And this is how we're going to be able to prove that a quadrilateral is a parallelogram. So the first way is called the parallelogram opposite sides converse. Again, don't memorize the number. You can either memorize the name or what it states. So this is our first way of proving that a quadrilateral is a parallelogram. And this states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if you notice in my figure, I'm showing that BC is congruent to AD, as well as AB is congruent to CD. Because I can show that both pairs are congruent, I can state that ABCD is a parallelogram. So if you were to asked to write an if-then statement based on the picture, what we could state here is that if AB is congruent to CD and BC congruent to DA, then ABCD is a parallelogram. Next one, again, don't memorize the number. You can either memorize the name or what it says. This one is the parallelogram opposite angles converse. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, notice in my picture, I have congruency marks on angle B and angle D. These are opposite angles, as well as angle A congruent to angle C. So because both pairs have congruency marks, I can say that ABCD is a parallelogram. And again, if you wanted to make a statement based off of the picture, you would have stated that if angle A is congruent to angle C and angle B is congruent to angle D, then ABCD is a parallelogram. This is our second way of proving that a quadrilateral is a parallelogram by showing that both pairs of opposite angles are congruent. The next one is not a converse, it's a theorem. Again, don't memorize the number. It's called the opposite sides parallel and congruent theorem. So if one pair, and it's got to be the same pair, of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So notice in my picture here, I've got a congruency mark and a parallel mark on side BC and AD. So because that same pair is both congruent and parallel, then I can say that ABCD is a parallelogram. So again, if I wanted to make a statement based on my picture, I could state that if BC is parallel to AD and BC is also congruent to AD, then I can say that ABCD is a parallelogram. Now I'm going to show you where if you have a parallel mark and a congruency mark, and if it's not on the same pair, then that's not enough information. And I'm going to draw a parallelogram for you to show you an example of where this fails. So this example that I'm showing here is the fail. It's not enough. I'm going to show you the picture. So this one does not have not enough information. So if I were to draw the same parallelogram, ABCD, but if I put the parallel here and the congruency here, it's not on the same pair, so this is a fail. Okay, so it must be on the same pair. So this is not enough information that would be a failure. If they would have given us more information, maybe another congruency mark on the red ones on BC and AD, then it would be enough. But this is not enough information because the congruency and the parallel must be on the same side. So the next one is the parallelogram diagonals converse. Again, don't memorize the number. We're going to memorize either the name or what it says. This states that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So notice in my figure here, I'm going to add in another point here in the middle so I can make my statement. I'm going to say E is here in the middle. So notice BE is congruent to ED and AE is congruent to EC. That tells me that those diagonals were bisected. So in words, I can make two statements about this. I could either state that if BD and AC bisect each other, then ABCD is a parallelogram. That's one statement you could make based on the picture. You could have also said that if BE is congruent to ED, meaning it's bisected, and AE congruent to EC, then ABCD is a parallelogram. So two different ways that we could make a statement about what we see in that picture. But if you're not given a picture, the converse just says if the diagonals bisect each other, then the quadrilateral is a parallelogram. This is our fourth way of proving that a quadrilateral is a parallelogram. So we have 5 ways. So we have these converse, the 3 converses. We have the new theorem that's parallel and congruent. And we also have the definition that we learned. So let's go ahead. And the next slide is like a summary of the 5 ways. The next slide just summarizes everything that we just talked about plus the definition. So there's 5 ways to prove that a quadrilateral is a parallelogram. The first way is to show both pairs of opposite sides are parallel. That's the definition. And then the next one, show both pairs of opposite sides are congruent. That was our parallelogram opposite sides converse. Then to show one pair of sides are parallel and congruent, that was the new theorem we just learned, to show that the one pair, the same pair, is both parallel and congruent. And then number 4, show both pairs of opposite angles are congruent. That's the parallelogram opposite angles converse. And then the last one, number 5, which was on the slide just before this, show that the diagonals bisect each other, which is the parallelogram diagonals converse. So we're using the 4 properties and their converses and the definition to show that something is, a quadrilateral is a parallelogram. The next slide is another summary, but now it's got pictures with it. The next slide, this is the same thing. It's just now I've added pictures to it. So again, the first one is the definition. The next one is to show both pairs of opposite sides are congruent. So again, that's our parallelogram if you want to know the name of it. Parallelogram opposite sides converse. The next one is to show both pairs of opposite angles are congruent. Again, that's called the parallelogram opposite angles converse. And then to show that one pair of opposite sides are congruent and parallel, that's the new theorem that we learned. So opposite sides, parallel, and congruent theorem. And again, you can reverse the order there. You could have said opposite sides, congruent and parallel. Doesn't matter as long as you've got both a congruency mark and a parallel mark on the same pair of sides. And then the last one is the parallelogram diagonals converse. And that's just the name of all of these. So these are your 5 ways of proving that a quadrilateral is a parallelogram. So this is where we're going to start bringing in our proofs. And again, if you know these converses, the definition in this new theorem, then the proofs are not going to be that difficult. So if you know your properties, it won't be that bad. So it says to state the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. So if I were to just give you that picture with A, B, C, D, and E labeled in there and no markings on it, no congruencies or parallels, I could not say that that quadrilateral is a parallelogram. But as soon as I start adding in congruency marks and parallel marks, then I'm able to say that that quadrilateral is a parallelogram. So for number 1, if I add in the congruency marks, and again, this should state that BE is congruent to ED and CE is congruent to EA. So BE is here, it's the diagonal, and then CE over here, as well as the EA. So this shows me that these diagonals have been bisected. So the way that I can state that this ABCD is a parallelogram, I'm going to use my parallelogram, diagonals, converse. And again, what that one states, I'm going to restate it down here. Just say it again, just to help it reinforce so you can memorize this. If diagonals of a quadrilateral bisect each other, then it's a quadrilateral. Then it's a quadrilateral. The next one, it says to put markings on BAD. So BAD is over here, and it's congruent to angle DCB, and as well as ADC, this one over here, congruent to CBA. All right, so those are my congruent angles. So notice both pairs of opposite angles are now shown as congruent. So the one that the name of this one is the parallelogram, opposite angles, converse. And again, what that one states is that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. For number 3, this one is giving me that BC is parallel to AD, that parallel mark, and AB is parallel to DC. This is the definition of a parallelogram. So number 3, definition of a parallelogram. And that definition is if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. Yes? So if I add in the congruency marks for number 4, add a different color here. So it's telling me for number 4, BC is congruent to AD and AB congruent to DC. So let me add in markings 1, 2, 3, 1, 2, 3. Okay, so because these are congruent sides, both pairs, number 4 is going to be the opposite, the parallelogram, opposite sides, converse. So that's the name of it. And again, you're either memorizing the name or you're memorizing what it states. And then this one says if both pairs of opposite sides are congruent now instead of parallel, then the quadrilateral is a parallelogram. And now for the last one, this one is called the opposite sides parallel and congruent theorem. And what this one states is that if one pair, and it's got to be the same pair, one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. And I already had congruency marks and a parallel mark on it. So here, if I just highlight, so it was given to me that BC is both parallel and congruent to AD. That would be enough to prove that that's a parallelogram. So these are the 5 ways that you would prove that a quadrilateral is a parallelogram. They're not going to necessarily give you all of this all at once. You're just going to take it one step at a time. So we'll try another example. This time we're going to find values of x and y. So example 2, it says, for what values of x and y is quadrilateral PQRS a parallelogram? So notice everything that's in my picture are things along the sides. So what I'm going to be using here to prove or to find the values of x and y is I need to show that the sides are congruent. So I'm going to be using the parallelogram, opposite sides converse, to show or to get the values of x and y. And again, to restate what this says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. I've already written this multiple times, but just to reinforce it. So what I'm going to do here to find x, I'm going to be setting PQ equal to SR because I know opposite sides are congruent. So I'm going to be solving PQ, which is x plus 9, and I'm setting that equal to 2x minus 1. I need to get my x's together, and I need to get my numbers together. So I'm going to subtract x. You could also move the 2. It doesn't matter. Then I'm going to add 1. I get 10 equals x. So my x value is 10. Now, just to show that they're congruent, remember PQ is x plus 9. So if I put a 10 here, the length of PQ is going to be 19. Just to check SR, it should be the same number, 2x minus 1, 2 times 10 minus 1, 20 minus 1, and it is also 19. So I've just shown that PQ is equal to SR. Now to find Y, I'm going to do the same thing with the other pair of opposite sides. Set them equal to each other. So now to find Y, I'm going to set PS equal to QR. PS is Y. QR is x plus 7. You're like, oh no, I got two variables. What do I do? Well, what I'm going to do is I'm going to take the x I just found and plug it in. So I'm going to end up putting in y equals 10 plus 7 and y equals 17. So now for PS, PS was y, so PS equals 17. And then for QR, that's equal to x plus 7. So if x was 10, 10 plus 7, QR is also 17. So my two values will be x equals 10 and y equals 17. So for example 3, again, it wants us to find the values of x and y. That would make quadrilateral ABCD a parallelogram. So what I'm going to be using here is my parallelogram, opposite angles, converse. Because if I can show that these opposite angles are congruent, then I can state that this is a parallelogram. So I'm going to find x, I'm going to be setting angle A equal to angle C. Angle A is 3x minus 32, and angle C is 2x. I'm going to move my x's together by subtracting 3x. Negative 32 equals negative 1x. Can't have a negative variable. Divide by negative 1, and x equals 32. Now, to show the value of angle A and angle C, we'll plug it in. Angle A was equal to 3x minus 32. 3 times 32 minus 32, 96 minus 32, and angle A equals 64 degrees. To show that it equals angle C was 2x. 2 times 32, 64. So angle C also equals 64 degrees. Now I also have to show the other angle. So I'm going to solve for y now. So now to find y, I'm going to set angle B equal to angle D. So angle B is 4y. Angle D is y plus 87. And then now I'm going to combine my like terms by moving the y over. 3y equals 87. Divide by 3. And y equals 29. So now I'll plug it in. Angle B was 4y. So 4 times 29. Angle B equals 116. Angle D is equal to y plus 87, 29 plus 87, and angle D also equals 116. So my two values for x and y are going to be x equals 32 and y equals 29. So we're going to write a 2-column proof. Let me go ahead and set it up. My given is already labeled in my picture. So I have statements and reasons. So I'm going to state the given. Angle ADB is congruent to CBD, and angle ABD is congruent to angle CDB. It wants me to prove that ABCD is a parallelogram. So if I go and I look at my picture where these angles are located, so ADB and CBD are these with the single marks. And then I have the other ones with the double. Now, I'm reaching back to a prior chapter, and these things that I just highlighted here, these are actually alternate interior angles. However, what we're going to use is the alternate interior angles converse, which stated that if alternate interior angles are congruent, then the lines are parallel. So that's what I'm using here, because I've already stated that these angles are congruent. So now I can state that side AB is parallel to CD, and AD is parallel to CB, and this reason is the alternate interior angles converse. Remember, the converse for all these special angle pairs proved that the lines were parallel. Now that I can add in my parallel marks, AD parallel to BC and AB parallel to DC, now what I can do is state that ABCD is a parallelogram. ABCD is a parallelogram by the definition of a parallelogram, because both pairs of opposite sides in my quadrilateral are parallel, so this is a parallelogram. So the definition. So if you know your properties and your converses and all these theorems, these proofs will not be that difficult. One more proof, just so we can practice. And we're going to do this on Friday. We'll do extra proof practice. So I'm going to draw a parallelogram in here. And I'm going to label it as A, B, C, D. And I'm going to give in that AB is parallel to DC, and that AB is also congruent to DC. So let me add in those marks. So they're going to be both parallel and congruent. I want you to prove that AD is congruent to BC. So this time we're not proving that it's a parallelogram as the final step, but we are going to prove it in the steps. So let's go ahead and set up the statements and the reasons, because we can already see it's a parallelogram, but we have to state that. So let me make my statements and my reasons. So number one, AB parallel to DC, and AB is also congruent to DC, and this is given. Now, because I have one pair of sides that's both parallel and congruent, my next statement is that ABCD is a parallelogram. And my reason is the opposite sides parallel and congruent theorem. And now, because I know that this is a parallelogram, I can state that the thing I'm trying to prove is true. So because this is a parallelogram, I could now add in congruency marks to AD and BC, which is what I'm trying to prove, that AD is congruent to BC. And the reason why I can state that is because opposite sides in a parallelogram are congruent. So my parallelogram, opposite sides theorem. So remember, the theorem is describing the properties of the parallelogram. The converses are proving that something is that a quadrilateral is a parallelogram. So again, this one states that if a quadrilateral is a parallelogram, then opposite sides are congruent. So again, on either of these reasons, you could have also restated it if you didn't remember the name. So you could have also said if a quadrilateral is a parallelogram, which is what we stated in statement 2, then opposite sides are congruent. That's what that theorem states. Now, statement 2, or the reason number 2, what this one states is if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So that's what this name, what that theorem states. So that is it. Nice and easy proofs, not very many steps. If you know your properties, your theorems, your converses, the definition, and then also reaching back to those alternate interior and consecutive interior chapter, then the proofs will not be that challenging. We will get more in depth when we see the special quadrilaterals like squares, rectangles, and rhombuses, and that's where we're going to bring in our congruent triangles as well. There's a question in the homework where it gives you 4 order pairs. You're going to have to graph them, and you have to show that it's that quadrilateral is a parallelogram by either doing the distance formula to show that the sides are congruent, or doing the slope formula to show that the sides are parallel. So when it gives you 4 order pairs, you need to use that prior knowledge to show that something's a quadrilateral, that quadrilateral is a parallelogram by using these 5 reasons: showing sides congruent, angles congruent, sides parallel, things like that.